Hi guys, and welcome to another video. And in this particular video, this is grade 12 maths analytical geometry, circles and tangents part 2. If you haven't watched part 1 already, please watch part 1 before you watch this video. In part 1, we've already answered the length of OK in Z form. So we've answered 4.1, 4.2, show that K is the point minus 12 and minus 6. And we've answered 4.3.1, the equation of the common tangent PKT in form y equals to mx plus c. So I'm going to continue with question 4.3.2, which is the coordinates of M. So the coordinates of M is the center of the small circle. So it's the center of the small circle. So let's have a look at that. Now, as we read earlier, they told us here that the radius of the circle is 3 times that of the circle centered at M. Therefore, we now know that OK is 3 times Km. So we wrote that down earlier. Therefore, if we have to let M equals to X and Y, which is the center of the circle, we've got K equals to minus 12 and minus 6. Therefore, what we can do is we can now work out the distance of Km in terms of X and Y using the distance formula. Also, remember that they tell us in this particular question that the centers of both circles lie on the line y equals to half x. So therefore, this line y equals to half x goes through both of the centers of the circle. So what does this mean? Well, it means that we will have an equation which is going to be formulated from the distance formula, and we have a straight line equation. Therefore, we can work out the coordinates of M using simultaneous equations. So let's go and write that down. So for 4.3.2, let's write that down. So 4.3.2, so therefore Km squared, remember Km squared, the distance formula, will be x2 minus x1 squared plus y2 minus y1 all squared. Now Km all squared. So let's have a look at that. So what do we know about Km? Well, first of all, OK, we've already worked out OK in third form, which is R. So OK is basically the square root of 180. So OK is the square root of 180 equals to 3 times Km. Therefore, Km will equals to square root of 180 over 3. So Km squared, and now substitute that. Km squared will be the square root of 180 over 3 all squared. x2 minus x1. Let's write that down. So there's my x value here. So minus 12 minus x. That's going to be minus 12 minus x all squared plus y2 minus y1, which is minus 6 minus y all squared. Let's write that down. Minus 6 minus y all squared. And what else do we know? Well, we also know that y equals to half x. So we got simultaneous equations. So if you had to now call that equation 1, call that equation 2, you can now substitute equation 2 in equation 1. So let's simplify. What do we have? Well, the square root, or rather the square root of 180 over 3 all squared. Let's put that in our calculator. Square root of 180 all over 3. All squared equals to 20. So that's 20 Here we got minus 12 minus x all squared. So let's just write that down, minus 12 minus x all squared. Here minus 6 minus y. So here we'll say minus 6. Now for y we're going to substitute half x, so that will be minus half x all squared. So now we got an equation in terms of x only. So now we can solve for x. So that will be 20 equals to, so let's square this binomial. Minus 12 all squared is 144. If I double the product of these two terms, I'll get minus 12 times x is 12x times 2, so plus 24x plus x squared. That will be minus 6 all squared will be positive 36. Let's double the product of these two terms. So what we'll get here, minus 6 times minus half x is positive 3x times 2 will be, that will be positive 6x. Let's double check. Minus times minus plus 6 times half is 3x. So 3x times 2 is 6x. Square the last term, well, 4x squared. So as you can see, we can have a quadratic equation. So therefore, let's make one side equals to 0. Now, so we got x squared plus 1 over 4x squared. So remember, 1 plus 1 over 4 will be 4 over 4 plus 1 over 4, which is 5 over 4x squared. Now, if for some reason you don't like fractions, well, you can just go and use your calculator. 5 over 4. Here, got 24x plus 6x is plus 30x plus 30x. 24x plus 6x is plus 30x. And here we're going to have 144 plus 36. So let's just put that in our calculator. 144 plus 36. We just simplify here. And minus 20, because we're going to bring this 20 over to the right hand side. That's equal to 160. So that's going to be plus 160. Now, in this particular quadratic equation, you can use the quadratic formula to solve for x. So once again, I'm just going to use calculator. So let's go to mode and equation, which is 5. Option number 3 should enable me to factorize this. 5 over 4, 30, and positive 160 equals to. So I've got minus 8 and minus 16. So therefore, x equals to minus 8 or x equals to minus 16. Let's go back and write our factors. So therefore, that will be x plus 8 and x plus 16. Okay. Now, in place of this, you could very well use your quadratic formula here. Another way you could have done it is that you could have just multiplied across here by 4 and you could have simplified it a little bit more. Alright, so therefore let's go and conclude. What do they want? The coordinates of m. So if you look here, the coordinates of m, as you can see here, the coordinates of k has the x value negative 12. So therefore the coordinates of m has to be a smaller negative value. So therefore, let's choose between the two. So if you look carefully, it can't be minus 8. It has to be minus 16 because it's to the left of point K. Alright, so therefore M has to be minus 16. Now let's go find the Y value. Now remember that the Y value, we can get it by looking at this equation, y equals to half x. So therefore it will be y equals to half times minus 16, which is equal to minus 8. Therefore m is going to be minus 16. The y value is minus 8. Okay, right. So that's that question done. So the coordinates of m is equal to minus 16 and minus 8. You can just write that. The next question, the equation of the smaller circle in the form x minus a all squared plus y minus b all squared equals to r squared. Now, if you look at this, we've already solved for the radius. So we know km is the square root of 180 all over. So we know that r is equal to the square root of 180 all over. And we've got the center of the circle. So therefore, remember, for a circle whose center is not at the origin, it will be x minus a all squared plus y minus b all squared equals to r squared. So we're just going to substitute our values here. X minus a. So therefore, we need to change the sign of this particular value here. So x minus a, so we're going to write x plus 16, and we're going to write y plus 8, and for r squared, we're just going to square that. Alright, so let's go and write that down. As you can see, we know that the coordinates of the center, so we'll write down x. Let's change the sign so that plus 16 all squared plus y, change the sign, plus 8 all squared equals to r squared. So that will be the square root of 180 over 3 all squared. So we can write it as x plus 16 if you want to simplify it, squared plus y plus 8 all squared equals to all over 3 all squared, that's equal to 20. And that's the equation of the circle centered at A. So there you go. 4.4. For which values of r will another circle with equation x squared plus y squared equals to r squared intersect the circle centered at M at two distinct points? For which values of r? So let's go look at that very, very carefully. So if you have to look at that here, you'll be able to see that we have the following, that the radius of the circle centered at O is square root of 180. And if we look at this, here we have square root of 180 over 3. So therefore, r must be greater than, so let's write it here, r must be greater than square root of 180, and it has to be less than, remember, if it wants to cut the smaller circle at 2 points, so it has to be firstly greater than square root of 180. So therefore, if it wants to cut the circle at 2 times here, it has to be now less than square root of 180 plus root 180 over 3 plus root 180 over 3. Okay, so it'll be as follows. So it'll be square root of 180 plus the radius is root 180 over 3. So it'll be root 180 over 3 plus root 180 over 3. So the solution will be as follows if we simplify it. Plus square root of 180 over 3 equals to 10 root 5. So basically, if we add the radius of the big circle to the diameter of the small circle, then it will cut the circle at 2 times. If it's greater than the diameter of that small circle, so if you say root 180 plus the diameter of the small circle, it's going to go outside here, so this is going to come on the outside. So we want it to come only on the inside for it to cut 2 times here. Okay, so if I just draw it, see, it must cut 2 times like that. Okay, so if anything bigger than that, it's going to be outside. Alright, so let's go look at the last question. Okay, so we can write here r is greater than 6 root 5. So that will be 4.3. Okay, let's go write that down. Okay, now Let's go look at the last question. In the last question, this is a very important one. It says another circle, x squared plus y squared plus 32x plus 16y plus 240 equals to 0 is drawn. Prove by calculation that this circle does not cut the circle with center m minus 16 and minus 8. Now in this particular question, I'm going to teach you how to find the center of a circle by completing the square. So we're going to learn how to find the center of a circle and the radius by completing the square. So let's look at 4.5. So in 4.5, we have the following. 4.5, let's write the question down. So what do we have here? Square. Now remember that when you're completing the square in an equation, what we have to do is, once again, we have to add and subtract. Once again, add and subtract half the coefficient of x and y. So because we've got two variables here, right? So it's going to be, let's group them, x squared plus 32x plus y squared plus 16y. Move this 240 to the right hand side, it will be minus 240. So therefore we'll have x squared plus 32x. Now remember what we're going to do is we're going to say plus, we're going to add half the coefficient of x all squared. So it's going to be plus 32x, so it's going to be positive 16. Half of 32 is 16 squared plus y squared plus 16y, and once again you're going to add half the coefficient of y all squared. So it will be positive 8 all squared equals to minus 240. Now whatever you did on the left hand side, you're going to do on the right hand side. So you added half the coefficient of x all squared, so you can also add half the coefficient of x all squared. So plus 16 all squared, and we added half the coefficient of y all squared, so you're going to do the same thing with this. So plus 8 all squared. Now what's left for us to do is to write in the form of a circle, standard form of a circle whose center is the origin. So what do we have here? X minus a all squared plus y minus b all squared. So let's just put that part in there, equals to r squared. So for your x minus a all squared, so you'll take that without the square, put it in there. Plus 16, that's why I include the sign, is very important, because now I'll just write positive 16 like so. Y without the square, put it in there, and the positive 8, just write it like so. Okay, and then this I'll just put it in the calculator. Where it is going to be positive, we have plus, and in brackets 8 squared equals to 80. So therefore now we've got 80. So therefore the center of the circle, let's call it C, will be minus 16 and minus 8. Remember to change the signs. And r squared is equal to 80. Therefore r is equal to the square root of 80. So let's go answer the question now. What does the question say? It says another circle, x squared plus y squared plus 32x plus 16y plus 240 equals to 0 is drawn. Prove by calculation that the circle does not cut the circle with center minus 16 and minus 8. So therefore you will notice that the centers of both the circles will be the same. Minus 16 and minus 8. Now let's compare their radius or radii. So this radii is root 18, and the radii of small circle is r squared equals to, remember, r squared equals to 20, so it will be r is equal to root 20. So what does that mean? So the radii is not the same. Therefore, if they have the same center and different radii, they will never cut each other. Now listen, that will be the solution with this particular question. If you haven't subscribed already to JL Maths, please do. Also check out all videos at jlmaths.com in order of the work schedule, like my Facebook page, Justin Lazarus Mathematics. And I'll catch you in the next video.